Hi dear children, welcome to chemistry class. In the previous two videos we were learning about electrochemical cell. We have completed the galvanic cell and started the electrolytic cell. Before starting the class we should remember some important points related to electrolytic cell. As you know, an electrolytic cell is an electrochemical cell that convert electrical energy into chemical energy. During electrolysis, that is when electricity is passed through an electrolyte, dissociation of electrolyte takes place. As a result, the cations are attracted towards the negatively charged electrode cathode and anions are attracted toward the positively charged electrode anode. Remember, anions migrate towards anode and cations are migrated towards the cathode. The sign of anode and cathode in an electrolytic cell is just opposite to that of a galvanic cell. So, the sign of anode is positive and that of cathode is negative in an electrolytic cell. The process taking place at anode is oxidation and that of cathode is reduction. Hope this much is clear for you. Today we are going to learn about electrolysis of molten and aqueous NaCl. Here we go. Electrolysis of molten sodium chloride. We know ions are responsible for the conduction of electricity by the electrolytes. But NaCl in solid state is not an electrical conductor because its ions have no freedom of movement. Also we know ions of the electrolyte can move freely in molten state or in aqueous solution. When electricity is passed through molten sodium chloride, electrolyte dissociate as positively charged sodium ion Na+ and negatively charged chloride ion Cl-. Now the ions are free to move. The reaction can be written as NaCl gives Na+ plus Cl-. See which ion is attracted to the positive electrode. As you know, anions are attracted towards the anode, right? So Cl- migrate towards anode. What about the process at anode? Oxidation or reduction? Absolutely oxidation. So the reaction is Cl- gives Cl plus 1 electron. Chlorine exists as diatomic molecule. Since the chlorine is unstable, it combines with another chlorine atom to form Cl2. So the gas liberated at anode will be chlorine. Now which is the ion attracted to negative electrode cathode? Na+. So this ion will undergo reduction. So the process taking place at cathode can be written as Na+ plus 1 electron gives Na. Now don't you get a clear idea of products obtained at anode and cathode? When molten NaCl is electrolyzed, chlorine gas is liberated at anode and sodium is deposited at a cathode. Next, we will see the electrolysis of sodium chloride solution. The ions present in sodium chloride solution are Na+, Cl-, H3O+, and OH-. H3O+ hydronium ion, OH- is hydroxyl ion. Since it is a solution, the water molecules are also present in this. We know during electrolysis, cations migrate towards cathode and anions migrate towards anode. But here, more than one cations and anions are present in this electrolyte. Also we know only one particular ion will be discharged at their respective electrode. So how do we decide which particular ion will be discharged? Let us examine the reactions taking place at cathode and anode. Among these, which are the ions attracted to negative electrode? You know negative electrode is cathode. That is, cations migrate towards cathode, right? So Na plus and H3O plus ions are attracted to cathode. But the water present in this solution shows a greater tendency to get reduced than sodium ion and hydronium ion. As a result, what happened? Hydrogen is liberated at a cathode. The equation for the reduction can be written as 2H2O plus 2 electron gives H2 plus 2OH minus. Water accepts 2 electrons and liberate hydrogen at a cathode. Similarly, anions present in this electrolyte, that is Cl- and OH- ions, move towards the positive electrode anode. While comparing the reactivity of these ions with water, Cl- ion shows a greater tendency to get oxidized. Hence, chlorine gas is liberated at the anode. The oxidation reaction taking place at anode can be written as 2Cl- gives Cl2 plus 2 electron. As a result of electrolysis of NaCl solution, chlorine is obtained at anode and hydrogen is obtained at a cathode. In the solution, NaOH is obtained. Alright, let's conclude today's class. In the beginning, we discussed about the electrolysis of molten NaCl. In molten NaCl, sodium is liberated at a cathode and chlorine is liberated at an anode. In the case of sodium chloride solution, 4 types of ions are present in this electrolyte, 2 from the NaCl and 2 from the water. Along with these ions, water molecule is also present. Comparing the reactivity of anions with the water molecule, chloride ion shows a greater tendency to get oxidized. Hence, chlorine gas is liberated at the anode. But while comparing the reactivity of cations with the water, water shows a greater tendency to get reduced. Hence, hydrogen gas is liberated at the cathode. The products obtained at anode and cathode is different for the electrolysis of molten and aqueous NaCl. Okay, students, see you in the next class. Thank you.